Hey guys, now this next one, it's kind of fun. We just have to look with it, and this is the one time they're giving you permission to assume if it's drawn to scale or not, okay? It says, judging by appearance, classify each quadrilateral in as many ways as possible. Well, on this first one, does it fulfill any of the definitions that we had earlier? All right, the first thing you should say, it has 4 sides. So I know at most specific I'm going to get is really a quadrilateral. I don't have any parallel sides. It's not a kite because I don't have my adjacent sides are congruent. It doesn't work. So let's look at the next one. Obviously, we can say it's a quadrilateral. And I'm going to abbreviate quadrilateral as quad from here on out just to save time and my chance of having horrible spelling. Now, what do I know about the opposite sides here? They look like they're going to be parallel. So by appearance, I can say it's a parallelogram. Great. Now look at the next one. Obviously we know it's a quadrilateral. It has 4 sides. Kind of like no-brainers on this one, right? But looking at this, are these 2 segments congruent? These 2 segments are congruent. I have no parallel sides. That throws out any parallelogram, any trapezoid type of thing, but I do have the 2 pairs of congruent adjacent sides. Notice I'm making sure I fulfill the definitions, so I get a kite. Remember, in geometry we think if, then, conditionally. If I fulfill the definition, then I know the traits or what it's called. So I know no parallel sides, 2 pairs of congruent adjacent sides, I must have a kite. Then on the next one, we have here, it looks like we have right angles. It looks like I have opposite pairs of sides are going to be congruent. I mean, not congruent, parallel, pardon me, and they are congruent, but parallel. So I know it's a quadrilateral. I know it's a parallelogram, but we also know without a doubt it's a rectangle. You guys start to see how we go from, I go from not as specific to more specific of a name. And then the next one, it looks like we have exactly 1 pair of parallel sides. So I have a quadrilateral, then I get more specific, it's a trapezoid. And then I'm looking at, I'm like, okay, the more specific than a trapezoid is an isosceles trapezoid. And those do look pretty much, I'm just doing a quick measurement here, yeah, the same. So I can be even more specific and call it an isosceles trapezoid. Excellent. Now let's do the next one. Actually, if I turn it like this, it might be easier to see. Is it a quadrilateral? Now that every one of you have rolled your eyes at that question, yes, I agree with you that it is. Okay, so we have a quadrilateral. My next question is it a parallelogram? Yes. It's not a kite, it's not a trapezoid. I have 2 pairs of parallel sides. So, I mean, that obviously blew that out of the water. Okay? Then my next question is, does it have 4 congruent sides? And the answer should be that yes, those are all the same. So it gives me a rhombus. And then I ask, do I have 4 right angles? So it's a rectangle. Great. But if it's a rhombus and a rectangle and a parallelogram, it must be a what? Square. It's all of those, all 5 names. All right, let's get our last example here. And please don't let these confuse you, but this is actually something I'll tell you right now on the final and on your test. So make sure you know this is on the final. Here we have a rhombus. The instant I tell you the type of quadrilateral, you better mark up the diagram. Now guys, the key to geometry is marking up the diagram. Those of you who don't like marking up the diagram, I'm sorry, you've just lost the key to geometry. All right, we have to know it. A rhombus has 4 congruent sides. So what do I mark? 1, 2, 3, 4 of the sides congruent. Now I want to know, it says the value of the variables, and I want the length of each side of the quadrilateral. Well, the cool thing is if I know the length of 1 of a rhombus, I know the length of all of these. So the cool thing is I got to figure it out. Now, these are all the same. I can't add them all together to equal something. They didn't tell me perimeter. But the cool thing is I don't care really what, as long as I just set 2 of them equal to each other. That's all I have to do, set 2 equal. Pick any 2 you want. Now here, I'm going to pick AC and AB. Now, don't ask me why I picked those two. It's just the two I picked. As long as I set those two equal, or any two that are the same equal, I'm going to get the same thing. So pick two different ones if you want. I'm going to go 18 minus x is equal to 2x minus 3. I'm going to add x over. Okay? Then I'm going to add 3 over to both sides. So that's 21 is equal to 3x. Go ahead and divide both sides by 3. X is going to equal 7. So when that's the case, I can plug and chug it in for the length of the sides. So I have AB equals BD equals CD. You notice I'm just doing all the sides at once because they're all the same. So how am I going to plug and chug? What's it going to be? Well, pick a side. I think CD is the easiest one to do it with. CD is x plus 4, so that's 7 plus 4, that equals 11. Well, all four sides are equal to 11. Really easy. All right, now let's look at the next one. We have to find, again, the values of the variables, and I want to know the length of the sides, but they tell me it's a square. So once again, what do we know about all the sides of a square? They're all the same. Now, don't be surprised if they do something like give you angle measurements and tell you it's a rectangle. Well, then you should realize that the measure of that angle is a right angle. So there shouldn't be anything like that that's earth-shattering. Use the definition of the figure to help you figure this out. But I want to know the length of the measure of the variable and the length of the sides. Well, I'm going to set two sides equal together. I'm going to go FG and IH because they both have F there. So I'm going to 5F minus 8 equals 3F plus 2. I'm going to subtract that over. I get 2F minus 8 equals 2. 2F is equal to 10. F is equal to 5. All right, so F is equal to 5. Then I'm going to go ahead and solve for G. I'm going to do the same thing here. I'm going to set them equal because the opposite ones here are equal. So I'm going to go G plus 6 is equal to 2G minus 5. Subtract the G over. I didn't do that very well. It should be a 1G there. Add the 5 over. 11 is equal to G. So those are my two variables. Now the cool thing is all the sides are the same, so I only need to once again plug and chug in once. You pick which side, which variable you want to use. I think I'm going to use, in this case, Fi, because it's just G plus 6. Well, what's G? Well, that's 11. So 11 plus 6 is equal to 17. Now, if I did this right, I should be able to plug in F into 5 into F and get the same thing. What's 3 plus 3 times 5 is 15 plus 2 is 17. So I know I did that right. So Fi is 17, but that means all the other ones have to be 2. So it means Fg, Gh, and Ih all equal 17 also. So I have my 3 segments. So it works out pretty easily. All right, guys, I hope this gets you started marking up your diagrams. Don't forget to worry about angles and parallel sides. All right, guys, have a great day.